This is a common failure point in AI development, a single, tangled wall of text. It's the result of blending rules, data, and user requests, hoping the model can sort it out. When a system lacks structure, it becomes brittle. A single edit to a background fact changes the agent's logic, and the whole thing shatters. To build a reliable agent, we have to stop treating prompts as transient instructions and start writing them as persistent, structural constitutions. Treating AI as a black box of prose is a dead end for production software. You need a design architecture that makes behavior predictable and observable. This transition from prose to architecture is the core focus of Imran Almad's book, 30 Agents Every AI Engineer Must Build. Moving past the chaos requires a specific structural anatomy for the agent's mind. The foundation is a two-layer architecture. We separate the system prompt, the agent's enduring identity, from the user prompt, the transient task. This ensures core rules remain intact. Even if a user request is malicious, the system prompt provides the boundary the agent cannot cross. Decoupling the agent's persona from the immediate task is necessary for building systems that can scale. Inside that system layer, we use the PTCF framework. It breaks the agent's cognition into 4 modular, debuggable components. Persona defines who the agent is. For a technical support agent, this section sets the expertise level and the specific tone it must use in every interaction. The task is the objective. We state it as a single, unambiguous job, like classify this ticket, so the agent doesn't have to guess what we want. Context is the landing zone for facts. We slot in data like SLA rules or privacy constraints here, keeping the information separate from the instructions. Finally, the format defines the output shape. This is a contract with your downstream code, ensuring the agent returns a structured JSON array every time. This structure makes debugging simple. If the facts are wrong, you fix the context. If the code can't read the response, you fix the format. We can make agents even more reliable by embedding direct examples into that context layer. This ranges from zero-shot, where the model has no examples, to few-shot, where we provide 2 to 5 specific demonstrations of the behavior we want. This image shows how a few-shot matrix handles support tickets. By analyzing the input, tone, and classification shown in these examples, the model can route incoming emails with much higher consistency. Embedding these structured examples transforms a static instruction into situational judgment. For complex logic, we have to engineer the actual reasoning pathways the agent follows. This diagram compares 2 common paths. On the left is chain of thought, the linear, step-by-step protocol. It's designed for methodical tasks like root cause diagnosis. On the right is tree of thought. Here, the agent explores multiple reasoning branches in parallel and synthesizes them into a final strategy. These structured pathways prevent the agent from jumping to the wrong conclusion when a problem requires deep analysis. We are moving past the era of trial and error prompting. The PTCF framework gives us a way to build agents that are as reliable as traditional software. This shift turns prompt writing into a disciplined engineering practice. By structuring language this precisely, you ensure that every interaction the agent has is grounded in its design. To get the full templates and code for these architectures, check out Imran Almad's book. You can find more deep dives at neurals.ca and by subscribing to this channel. Don't just prompt, engineer. I'll see you in the next one.